the astronaut was alone, the nearest human being almost 400,000 kilometers away. The harsh, unfiltered sunlight cast long shadows across the desolate landscape as she carefully made her way across the regolith, each step raising a small cloud of ancient dust that had remained undisturbed for billions of years. Her mission was simple, yet profound: to venture where no human had gone before, into the permanent shadow of the lunar South Pole. As she approached the rim of Shackleton Crater, the pitch blackness loomed before her, a void so complete it seemed to swallow light itself. What secrets had been hiding in these dark regions for billions of years? What ancient cosmic history lay preserved in these cold traps that never see the sun? And what might humanity discover when we finally pierce this darkness? The Moon, our closest celestial neighbor, orbits Earth at an average distance of 384,400 kilometers. Despite its proximity, and despite humans having walked on its surface over half a century ago, vast regions of our lunar companion remain unexplored and shrouded in mystery. Perhaps the most enigmatic of these regions are the permanently shadowed areas near the lunar poles, areas where sunlight has never reached for billions of years, creating some of the coldest places in our solar system. These dark regions have captured the imagination of scientists, space agencies, and conspiracy theorists alike, all wondering what might be hidden in the eternal darkness. The Moon's relationship with Earth is, in cosmic terms, rather peculiar. Unlike most moons in our solar system, our Moon is unusually large compared to its parent planet, roughly 1/4 of Earth's diameter. This has led to a gravitational dance that has locked the Moon's rotation to its orbit, meaning the same side always faces Earth. This phenomenon, known as tidal locking, is why we always see the same familiar face of the Moon from our vantage point on Earth. For centuries, humanity could only wonder what the far side looked like, until the Soviet Luna 3 probe finally captured images of it in 1959. But even with this mystery solved, another remained. The Moon's axis is tilted at only about 1.5 degrees relative to the ecliptic plane, compared to Earth's 23.5-degree tilt. This slight tilt means that areas at the lunar poles experience extreme lighting conditions, with some peaks in near-constant sunlight and nearby craters in perpetual darkness. Indeed, these permanently shadowed regions, or PSRs as NASA refers to them, have never seen sunlight since the Moon's formation approximately 4.5 billion years ago. Located primarily within deep craters near the lunar poles, these areas maintain temperatures as low as 248 degrees Celsius, or just 25 Kelvin above absolute zero. To put that in perspective, that's colder than the surface of Pluto. At these temperatures, these dark craters become perfect cold traps, areas so frigid that volatile compounds that would normally evaporate or sublimate instead remain frozen for billions of years. And this is where our story truly begins, for these cold, dark regions may hold the key to understanding not just the Moon's history, but potentially Earth's and even our solar system's past as well. The most tantalizing substance believed to be hiding in these shadows is water ice. But how would water end up on the seemingly barren lunar surface? There are several potential sources. Comets and water-rich asteroids have bombarded the Moon throughout its history, delivering water molecules to the surface. The solar wind, a stream of charged particles flowing from the Sun, contains hydrogen ions that can combine with oxygen in lunar soil to form water. Outgassing from the Moon's interior during its more geologically active past may have released water vapor that eventually found its way to these cold traps. In most regions of the Moon, any water would quickly evaporate in the harsh sunlight or be broken apart by solar radiation. But in the permanent shadows, temperatures are so cold that water molecules that find their way there become trapped, potentially accumulating over billions of years. The quest to confirm the presence of water ice in these dark regions began in earnest in the 1990s. The Clementine mission in 1994 used radar to suggest the presence of ice, but the results were inconclusive. Then, in 1998, NASA's Lunar Prospector detected elevated hydrogen concentrations near the poles, indirectly suggesting the presence of water. But it wasn't until 2009 that NASA's L-Cross mission deliberately crashed a spent rocket stage into Cabeus C, crater near the South Pole, creating a plume that contained approximately 155 kilograms of water vapor and water ice. This was the smoking gun, definitive proof that water ice exists in the Moon's darkest regions. Subsequent missions have mapped these resources in greater detail. India's Chandrayaan-1 Chandrayaan-1 mission carried NASA's Moon Mineralogy Mapper, which detected the chemical signature of water and hydroxyl groups across the lunar surface, with higher concentrations near the poles. NASA's Lunar Reconnaissance Orbiter has mapped the surface temperature of the Moon, clearly identifying the permanently shadowed regions where ice could survive. And in 2020, NASA confirmed the presence of water molecules even in sunlit regions of the Moon, though in much smaller quantities than in the shadowed areas. But water ice isn't the only treasure hiding in the lunar shadows. These pristine cold traps are like cosmic time capsules, preserving volatile compounds that have been delivered to the Moon over billions of years. Scientists believe these regions may contain ammonia, methane, carbon dioxide, and simple organic molecules, the basic building blocks of life. Some of these compounds may have been delivered to Earth by the same processes, potentially playing a role in the origin of life on our planet. By studying these preserved volatiles on the Moon, we might gain insights into the conditions that existed in the early solar system and the processes that made Earth habitable. The darkness of these regions doesn't just hide treasures. It may also conceal dangers. The same permanently shadowed craters that preserve water ice are also among the most challenging environments for exploration. The absence of sunlight means that traditional solar panels would be useless for powering equipment. The extreme cold presents challenges for the functioning of electronics and mechanical systems. The terrain within these craters is largely unknown and potentially treacherous, with steep slopes and boulders hidden in the darkness. And the regolith in these regions may have different properties than the soil in sunlit areas, potentially posing mobility challenges for rovers or astronauts. And so, with these challenges in mind, space agencies around the world are developing specialized technologies to explore these dark regions. NASA's Volatiles. Investigating Polar Exploration Rover, Viper, is scheduled to land near the lunar South Pole in 2024 to search for water and other volatiles. It will carry its own lighting systems and is designed to operate in the extreme cold. The Artemis program aims to return humans to the lunar surface, with a focus on the South Polar region, where astronauts might be able to reach some of the permanently shadowed areas. China's Chang'e missions have also targeted the polar regions, with Chang'e 4 making the first-ever landing on the far side of the Moon in 2019, and future missions planned to explore the South Pole. Beyond the scientific value, these hidden ice deposits have immense practical significance for future lunar exploration and potential colonization. Water is, of course, essential for human survival, but transporting it from Earth is prohibitively expensive. Launching a single kilogram of material to the Moon costs tens of thousands of dollars. If explorers could instead harvest water from the lunar surface, it would dramatically reduce the cost and complexity of maintaining a human presence there. Moreover, water can be split into hydrogen and oxygen through electrolysis, providing breathable air and rocket propellant. This concept of living off the land or in situ resource utilization as NASA calls it, could transform the Moon from a destination for brief visits into a sustainable outpost. This potential for resource utilization has not gone unnoticed by governments and private companies. In fact, it has sparked debates about lunar resource rights and the applicability of existing space treaties to resource extraction. The 1967 Outer Space Treaty, the foundation of international space law, states that no nation can claim sovereignty over the Moon, but it is less clear about the extraction and use of resources. The United States, through the Artemis Accords and domestic legislation, has taken steps to establish a framework for resource utilization, while other spacefaring nations are developing their own positions. This legal uncertainty hovers over the lunar ice deposits like a shadow of its own, raising questions about who will have access to these resources and under what conditions. But perhaps the most captivating aspect of these dark regions is their potential to harbor evidence of the Moon's mysterious past. The Moon's surface in sunlit areas has been continually modified by micrometeorite impacts, extreme temperature, fluctuations, and radiation from the Sun, a process called space weathering. But in the permanently shadowed regions, this weathering is minimized. The regolith there may preserve a record of the Moon's surface as it was billions of years ago, potentially including evidence of ancient volcanic activity or the massive impacts that shaped the early Moon. Some scientists even speculate that these regions might contain material ejected from Earth billions of years ago, preserved like insects in amber, offering a window into our own planet's distant past. One particularly intriguing theory concerns the Moon's formation itself. The leading hypothesis, known as the giant impact theory, suggests that the Moon formed when a Mars-sized body called Theia collided with the early Earth about 4.5 billion years ago. This cataclysmic impact ejected material that eventually coalesced to form the Moon. However, there are still unanswered questions about this theory, particularly regarding the similarities in isotopic composition between Earth and Moon rocks. Could evidence that would help resolve these questions be preserved in the pristine regolith of the permanently shadowed regions? The possibility tantalizes lunar scientists. The darkness of these regions has also fueled more speculative theories. In the absence of direct observation, the human imagination has filled these voids with possibilities ranging from the scientific to the fantastical. Some have suggested that the extreme conditions might preserve meteorites or cometary material in a near-pristine state, potentially including extraterrestrial organic compounds or even fossils of microbial life that could have been transported between planets. Others, veering into the realm of science fiction, have proposed that these shadows could conceal evidence of past alien visitation or ancient lunar civilizations. While such ideas remain firmly in the realm of speculation without supporting evidence, they highlight the powerful grip these mysterious regions have on our collective imagination. Even more practically, these dark regions might someday be the site of human habitation, the edges of permanently shadowed craters where darkness meets light present unique opportunities. Nearby peaks of eternal light, areas that receive sunlight for the majority of the lunar year, could provide solar power, while the adjacent shadowed regions could supply water and protect habitats from radiation. Some architects and engineers have proposed building settlements into the walls of these craters, creating structures that would be shielded from the harsh space environment while having access to the necessary resources for survival. And yet, despite their promise, these dark regions remain largely unexplored. Our knowledge of them comes primarily from orbital measurements and remote sensing, like trying to map an ocean floor from a plane flying overhead. The true nature of these regions awaits direct exploration, either by sophisticated robots or by humans willing to venture into the darkness. The challenges are immense, but so too are the potential rewards. When we finally pierce this veil of darkness, what will we find? Ancient ice as pure as the day it was deposited? A treasure trove of cosmic chemicals? Evidence that rewrites our understanding of the moon's formation or even life's origins? Perhaps most profoundly, the permanently shadowed regions of the moon represent a frontier of exploration that is simultaneously alien and accessible. At a time when it seems like every corner of Earth has been mapped and catalogued, these dark craters remind us that there are still places in our cosmic neighborhood that remain untouched by human eyes or instruments. They are a testament to the fact that exploration is not just about distance, but about overcoming the barriers, whether of extreme cold, perpetual darkness, or technical limitations that have kept certain realms beyond our reach. As we stand on the threshold of a new era of lunar exploration, with multiple countries and private companies setting their sights on the moon, these dark regions beckon with their mysteries. The astronaut from our opening scene may soon become reality, a human explorer standing at the edge of darkness, preparing to take a step that reveals what has been hidden for billions of years. What treasures await in the moon's eternal night? What secrets of our cosmic neighborhood lie preserved in this frigid darkness? And how might these discoveries change our understanding of the moon, Earth, and our place in the solar system? Indeed, the darkest regions of the moon remind us that exploration is not just about reaching new destinations, but about bringing light to places where it has never shone before. As we venture into these shadows, we continue humanity's enduring quest to push back the darkness of ignorance and reveal the universe as it truly is. A universe that continues to surprise us with its wonders, even in places that have been our celestial companions for all of human history. The answers await in the darkness, if only we have the courage and ingenuity to look. The astronaut pauses at the rim of the crater, the stark boundary between blazing sunlight and complete darkness stretching before her. Her headlamp barely penetrates the void, a tiny beacon of human curiosity in an ancient darkness. As she takes her first step downward, the beam of light reveals what no human has ever seen before: the gleaming surface of ice that has waited in darkness for billions of years, holding secrets of our cosmic past, and perhaps the keys to our future among the stars.